make sure I record this. All right, so the reciprocal identities, you already know these. You already know that sine of x is equal to 1 over cosecant of x, right? You already know that. All right, and you also already know that cosecant of x is equal to 1 over sine of x. Now, you don't... Did someone just send you something? Yeah, they airdropped you. That was you, huh, Kyla?
Yeah.
Well, no, yeah. All right, so basically, you don't need to know that they're called the reciprocal identities. That's just what they're called. You need to memorize. You need to know these for sure, okay? We're going to use these a lot. The other reciprocal identities would be cosine of x is equal to 1 over secant of x. And by the way, people are very tempted to just write cosine equals 1 over secant. You need that x. You need cosine of what? It's cosine of x is equal to 1 over secant of x. Like, what if x was different and y was different? Kyla, what are you doing? You're making everyone laugh now.
I'm not doing anything.
Uh-huh. Mm-hmm. All right. So, secant of x is 1 over cosine of x. What's going on out there? Yo-chan.
Yo-chan's at the center of it.
He is, isn't he? All right. Well, anyone want to stay after? I'll give you extra credit if you tell me what's going on. Okay. Some of you.
Serious?
Nope. Some of you need it too. All right, here we go. Tangent, after that test. Tangent of x is equal to 1 over cotangent x. And cotangent of x is 1 over tangent x. So you should recognize all of those. Those are not new. If I tell you memorize those, you're like, yep, got those already. Okay, the next two are the quotient ones. And the quotient ones you already have too. You already know these. Quotient is, division. And we know that tangent of x is equal to the sine of x over cosine of x. You know that one. We talked about it. Did you lower it? It's hot in here.
Yeah.
Oh, good, because that thing was like, it turned on yesterday. It was saying things going to explode. It's too hot in here. Okay, and then cotangent of x is equal to, do you know this one? Cosine of x over sine of x. It's going to be the reciprocal of tangent, so you just flip them. Okay, so you need to know those. Those are going to be in your head. You're going to use those quite a bit. The Pythagorean identities. Here they come. If you have a unit circle, right? We're not going to do too much unit circle today, but we will get back to it. And let's say that you have a triangle in there. And what's the radius of a unit circle? It's 1, right? Unit circle is 1. And then this right here, this is the point xy. And we know that x is cosine of that angle. We'll call it theta. And we also know that y is sine of theta. So if I were to take this triangle, which is x is cosine. Well, let's call it cosine x, just so that we stay in this. And then this is sine of x, and this is 1. I can use the Pythagorean theorem to rewrite this. I can say that cosine squared x plus sine squared x is equal to 1. A squared plus b squared equals c squared. This right here is one of the most important identities that you're going to use. You're always going to remember that. Okay? Now, there's two other ones that follow from that. If we were to say cosine's not 0 and we were to divide everything by cosine, we would get 1 plus tangent squared x is equal to secant squared x. Okay, that's our other Pythagorean identity. And then we have one more. 1 plus cotangent squared x is equal to cosecant squared x. Okay, I forget these a lot. I mean, I've been teaching this for a long time, but those are the ones that I don't remember. So I'm going to show you a trick real quick. of how you can remember those. Like everyone remembers cosine squared plus sine squared equals 1. That's just something that you remember. But the tangents and the secants and the cotangents get a little confusing. So here's what I do. I know that cosine squared plus sine squared equals 1. Now, let's take everybody and divide everyone by cosine squared. Okay? Like if you're on a test and you forget it, you can do this really quickly. What is cosine squared over cosine squared? It's 1. What is sine over cosine? It's tangent, right? Sine over cosine. So sine squared over cosine squared is tangent squared. And then what's 1 over cosine squared? Well, what's 1 over cosine? Secant. And that squared would be secant squared. See? I got it from doing that. So my dad told me that one day. I'm like, how do I get kids to memorize this stuff? And then the other one would be take cosine squared plus sine squared plus 1, or equals 1, sorry, and divide everybody by sine squared instead. So if you divide everybody by sine squared, you'll get the other trig identity. So what's cosine squared over sine squared? That's cotangent squared. And what's sine squared over sine squared is 1. And 1 over sine squared is cosecant squared. So that would be this one right here. So if you're ever stuck, you can't remember them on a test or quiz, you'll remember 1 or cosine squared plus sine squared equals 1 squared. You'll just remember that because that one's easy. The other two will come from just doing that to them. Okay, let's get back. A couple more. Now I've got cofunction. Cofunction. This is what your cofunctions look like. The sine of pi over 2 minus x is equal to cosine of x. Okay? Also, cosine of pi over 2 minus x equals the sine of x. It has to do with their graphs and the shifting, the phase shift that you do. I know it's a little weird because x is negative and it's instead of x minus pi over 2, it's pi over 2 minus x. And then you also have secant and cosecant also work that same way. So the secant of pi over 2 minus x is equal to cosecant of x. I'm going to run out of room on this thing. And then cosecant of pi over 2 minus x is equal to secant of x. And then this cofunction also works for tangent and cotangent too. Same thing. So the tangent of pi over 2 minus x is cotangent of x, and cotangent of pi over 2 minus x is tangent x. There you go. So you need to know those. And that's just the graph. You can remember those pretty easily. Sine and cosine are a shift. Secant and cosecant look the same, but they're just a shift, and same thing with tangent and cotangent. Okay, and finally our last identities for today. There's a ton in this chapter, but for today, our last identities are the odd and even functions.
Can you go back?
Sure. To these? Yeah. Are you able to fit these in better than I am?
Yes.
Good, thank you. I write big and then I write small. All right, out of our 6 trig functions, 2 of them are even and 4 of them are odd. Okay? So the odd ones are going to be sine, cosecant, tangent, and cotangent. So what it means to be an odd function is if you take the sine of negative x, it's equal to the negative sine of x. Same thing with cosecant of negative x is equal to negative cosecant of x, bless you. And then tangent, same thing. Tangent of negative x becomes the opposite of tangent x, and cotangent. So they all 4 of those work the same. And you can remember that by doing arc sine. Remember when we were taking the arc sine of a positive, it was pi over 2, and arc sine of that negative was negative pi over 2 is the opposite answer. And you can think of a famous odd function as just the y equals x cubed function. If you plug in 2, it's 8. If you plug in -2, it's -8. It's just the opposite whenever you plug in the opposite. But even functions don't work that way. We only have 2 that are even, and they're the other 2 that are left. So if you take the cosine of -x, like if I take the cosine of pi over 4, I get rad 2 over 2. If I take the cosine of negative pi over 4, I still get rad 2 over 2. It doesn't affect it. One of the most famous even functions is just y equals x squared. If I plug in 3 and I square it, I get 9. If I plug in -3, I square it, I still get 9. It doesn't change the sign at all because it's an even function. And that's also true for secant. And so maybe you're sitting there going, wow, this is a lot to remember. This is just day 1 of this chapter. That's funny. Okay, are you ready? Did you write all those down? You want to catch up? Okay. The first one, these ones are kind of because it says use the trig identities to evaluate. You know me, I like to do things the best way, and I don't think this is the best way to do these problems. Like, it's asking me to find sine if cosine is 1/5. I really don't want to use a trig identity. I'd rather use a triangle. You know what I mean? Like, okay, let me show you. So your book's going to have you do this. Find sine of theta if cosine of theta is 1/5 and sine is positive. So sine and cosine are both positive, which means I'm in quadrant 1. Here's my theta. It's just a right triangle trig. I can set this up as cosine is adjacent hypotenuse, which would make sine. Yo-chan, what's 5 squared? Is it 10?
8.
Oh, 8. I was walking with my son after I said that to you, and I go, Andrew, he thought that 4 squared was 8. And she's like, no, it's 16. My 11-year-old. That's funny. All right, so this would be the square root. It's so rude. I know. I make mistakes like that all the time. Actually, I made 3 mistakes on the front page when I was grading. I'm like, why is everyone getting this one wrong? It was me. I got it wrong, yeah. All right, so that would be rad what, 24? Rad 24. So if I wanted to find the sine of theta, I would do opposite over hypotenuse, rad 24 over 5. And I should probably rationalize that. But they want us to use our trig identity to solve this. And you know what? I'm not going to do that. I'm not. Not for this one. If you want to set up a triangle, go ahead. Do you want to know what they wanted you to do? They wanted you to do this. Sine squared theta plus cosine squared theta equals 1. And they want you to square that, subtract it, take the square root. That seems like a lot of work when I can set up a triangle. Okay, the next one you can also set up a triangle too, so we're going to not do that one. But letter C is a little trickier. Letter C is different. Do you see how this is? This is to find the sine of theta minus pi over 2 just given this. Okay, we're not going to set up a triangle here. This is a little bit different. Now, as you can see, if you look back up to your cofunction, this doesn't look like your cofunction. Your cofunction says the sine of pi over 2 minus theta, or x, equals cosine of theta. This is theta minus pi over 2. They're switched. So here's how you do this problem. You're going to put a negative in front, and you're going to factor a negative out of this to make it pi over 2 minus theta. Is everyone okay with that so far? All I did was take the inside here, factored a negative to the front. That way, my negatives and positives switched, and now I have this. So now I have the sign of a negative term, whatever that is. We can cover it up. And this is what? Negative sine of pi over 2 minus theta. I just used 2 of our identities. No, I've only used 1 so far. All I did was I put a negative in front, switched those 2. Then, because sine is an odd function, I pull the negative outside of it. And now this is negative cosine. Because this right here says that that's equal to cosine. My cofunction identity says that. And then if I want to find, excuse me, negative cosine, and cosine is 0.34, my answer would be negative 0.34. There you go. And that's the answer.
So it equals negative cosine theta?
Yep, it does. Okay, so that's just those kind. We're not going to do those that much. The things that we're going to do more are going to be on the next page. So, go over to here. All right, we got 5 more. Hope we have time. All right, we're going to be simplifying these things. They're going to be kind of, a lot of stuff going on here. And we're going to simplify them so that they look not so complicated. Okay? So for the first one, what we're going to do to simplify is you're going to do some things. You're either going to try to factor. Okay, we'll factor some of these. We're going to add or combine them, add, subtract them. We might need a common denominator in order to do that because we might have some fractions like number 3, add or subtract. So you might need a common denominator. Another trick that we're going to do is we're going to use conjugates. I don't know if you remember conjugates. We did them with complex numbers and with radicals. We can do them with trig also.
Will we ever have like an imaginary number in this?
Yes, that's chapter 6. They're going to combine imaginary numbers with trigonometry. Demov's theorem. It's exciting. Okay, let's do number 1. Here we go. So when you look at this problem, you have sine x times cosine squared x minus sine x. So what we're going to do is there are 2 terms here, and we're going to factor sine x to the front. Okay? So I factor out a sine x, and I'm left with cosine squared x minus 1. Is everyone okay with that?
Yes.
Took the sine x, factored it to the front. Okay, now here's the thing. You know this little, by the way, whenever you see one of your functions squared with a plus or a minus 1, it's probably going to be the Pythagorean identities, but you can rearrange these Pythagorean identities, okay? Watch. If cosine squared plus sine squared equals 1, I can subtract 1 to this side, and I can subtract sine squared to the other side. That's allowed, because I know that that's an identity, it works. So I know that cosine squared minus 1 equals what? Negative sine squared. So I'm going to rewrite this. Sine x times negative sine squared x. And if I have a sine x times a negative sine squared x, I end up with negative sine cubed x. And that is completely simplified.
Why is that like helpful? Like why is that what's
Yeah, you actually, this would be very helpful when you get to calculus and you need to find the integral of this thing, of this original. To rewrite it like that, it would be so much easier to find it.
But we're not going to apply any of that.
This year?
Yeah.
No, we're just learning how to do them. Next year you will use them. All right, so let's do number 2. Okay, number 2, I can't factor anything out. They both don't have a sign. Now here's the other trick that I like to do. Whenever I see any of my cotangent, cosecant, or secant, I like to change those into, other things. Either cosine over sine, 1 over tangent, stuff like that. Personally, I like to get everything in terms of sine and cosine. I think that's really helpful. All right, so sine of t stays sine of t. Cotangent of t is cosine of t over sine of t. Does everyone agree with that?
So we're basically trying to put them all within the same trig function.
Yes.
Okay.
Yeah. These are hard today. They actually get easier when you do identities, like proofs, because it'll say equals something and you know what you're trying to get. It's actually easier. Right now we're just simplifying. We don't know what we're trying to get right now. We're just trying to get it simplified. Well, what does that mean?
I don't know. This is all pretty complex stuff.
It is. It is. Okay. So now we have sine of t plus, here we're going to multiply our fractions. So cosine t times cosine t is cosine squared t, and sine t times 1 is sine t. All right, now I want to combine these two. I want to add them up. And in order to add them up, I need to get a common denominator. So the common denominator between 1 and sine t is going to be sine t. So I need to multiply the first, this one right here, I need to multiply that top and bottom by sine t in order to get a common denominator. Okay. So I multiply at the top. Sine t times sine t is sine squared t. Multiply sine t times 1 is sine t, plus cosine squared t over sine t. And now I can combine those two because I have a common denominator. So I can combine them into one fraction. I'm showing all of my steps here just because this is brand new. Sine squared t plus cosine squared t all over sine t. And hopefully you recognize what the top is. 1. That one's going to show up a lot. Sine squared t plus cosine squared t equals 1. And what is 1 over sine t? No? Cosecant t. And that is simplified as far as you can go. Right? Trig goosebumps even. We went from this, sine t plus cotangent t cosine t, and we got it to be cosecant t. They're identities. They're the same thing. You know what an identity is, right? It's exactly the same. Like 2 times x plus 1 is the same thing as 2x plus 2. We just did an identity. This is what it's equal to. The other thing I want to tell you is some people think they can just square root stuff when they want to. Like on that test, some people square rooted some stuff they shouldn't have. But sine t plus cosine t does not equal 1. Okay? Sine squared t plus cosine squared t equals 1. It's like saying this. You know, 3 squared plus 4 squared equals 5 squared. Do you all agree with that? Yeah. It would be like saying 3 plus 4 equals 5. Like, let me just get rid of all the squares. You can't do that. You're not allowed to do that, okay? It doesn't. All right, we've got 3 more to go. Here we go. Oh, this one's a doozy. All right, so take a look at this one. We've got fractions again, and we need to combine them together. We need to add them. So we need to get a common denominator. So, no, you can't. Cross multiply would be if it's equal to something, then you cross multiply. Yeah. So our common denominator is we're going to need a 1 plus cosine, and we're going to need a sine. They're different things, so we need one of each. All right, so this is how I like to set these up. So I'm going to need a sine theta for both of them, and they're also going to need a 1 plus cosine theta. That's our common denominator between these two terms. So now let's look at the first fraction. Oh, I'll let you catch up to that. The first fraction is missing a what in its denominator? When you go from here to here, what's it missing? It's missing a sine. So I need to multiply this top and bottom by sine. And when I do that, I get sine times sine is sine squared. Okay? All right, over here.
Why don't you put the squared like on the outside of the theta? Like why you do it on the inside of the...
Ooh, good question. Sine squared theta means sine of theta squared.
Okay.
And that we don't like writing, it's a lot of parentheses and stuff, so we just put the squared here. It is not equal to the sine of theta squared.
Because then that's that angle.
The angle is squared, yeah. So it's very different because sine squared theta is sine theta times sine theta. But sine theta squared is sine of that angle squared. It's different. All right, so over here, we are missing top and bottom. We have the sine, but we're missing the 1 plus cosine. So we're going to multiply top and bottom by 1 plus cosine. So let's take this cosine and we'll distribute it in. Cosine times 1 is cosine. Cosine times cosine is cosine squared. All right, so now we have a common denominator. We can go ahead and add our fractions. People right here, they get kind of tempted to start canceling stuff out. Don't cancel anything out. There's no canceling. Okay, we're going to add them together. That's what our goal is, to get these all together. So I have sine squared theta plus cosine theta plus cosine squared theta all over sine theta times 1 plus cosine theta. All right, so I've made quite the mess. Now we're going to clean it up. Now, anyone notice anything up top? Yes, you have a sine squared plus a cosine squared. Now, they're not next to each other, but that's okay because addition is commutative, which means you can flip some stuff around. And so I can write sine squared plus cosine squared is 1. I still have that cosine up there, and this is all over sine theta times 1 plus cosine theta. Now, do you see where we're headed? Sometimes you can, like, what's that called? Like foreshadowing, like you see what's going to happen in the next couple of steps. It's mathematical foreshadowing. It's very exciting. All right, so then at this point, we have a 1 plus cosine up top and a 1 plus cosine on the bottom as factors. We can reduce, or as you like to say, cancel, which is wrong. Okay, so then you end up getting 1 over sine of theta, which we just saw in the last problem, is equal to cosecant theta. Dang, all of that equals that. Aren't these fun? No, yes. What? Yes, they are. Isn't that crazy? That's equal to that. That would be a really good identity to do one day. Okay, number 4. Right now this has a fraction. We want to rewrite it without a fraction. How are we going to do that? We're going to use conjugates on this problem. Okay? So, we're going to take 1 over 1 plus sine of x, and we're going to multiply top and bottom by its conjugate of the denominator. Do you remember conjugates? Conjugates, basically, they're binomials. They differ by 1 sign in the middle. So we want to multiply by 1 minus sine x. Yes. Okay. You're like, why would we want to do that? Well, I'll show you why. It's coming. All right, so we multiply the numerator, and we get 1 minus sine x. And then in the denominator, we're going to have to FOIL. Now you're like, oh, FOIL. FOIL with trig. It's not that bad. Plus conjugates, you know the O and I part, they cancel each other out. You remember that? Yeah? That's why they're so special. All right, so we FOIL and we get 1 times 1 is 1. Like I said, outside, inside, cancel each other out. You get a negative sine x and a positive sine x are gone. And then the middle, or the last term, is negative sine squared. Okay. Please don't start canceling things. You can only reduce, it's called reduce, it's not really called cancel, when you have factors, and then you can reduce factors, okay? Because you have to remember, if you had something like 2 plus 3 over 2 plus 5, you can't just do that. You're not allowed to do that, okay? No. All right, so over here, whenever I see a 1 with a plus or minus one of my trig functions squared, I got to think Pythagorean identity. And my Pythagorean identity is cosine squared plus sine squared equals 1. So if I rearrange that identity a little bit, what is 1 minus sine squared? It is. If I bring this sine squared over, 1 minus sine squared is cosine squared. You see that? This identity has like 3 identities in itself. Okay, so we have 1 minus sine x over cosine squared x. Okay, now still have a fraction, but now at least I have 1 term in my fraction instead of 2. So what I'm going to do is I'm going to take this and I'm going to split it up. 1 minus sine x is the same thing as 1 over cosine squared x minus sine x over cosine squared x. Do you all agree with that? It's the same thing. It's going from getting a common denominator and combining it to you have a common denominator and you've uncombined it. You've split them up. And now, what is 1 over cosine squared? Well, what's 1 over cosine? Secant, right? Secant. So 1 over cosine squared would be secant squared. Now over here, and I just got rid of the fraction. That's what I'm trying to do. Over here is a little tricky. Now watch this. I have sine x, and I have a cosine squared on the bottom. So I can write that as cosine times itself. You're allowed to do that. Cosine squared x is cosine times cosine. Sine is sine times 1. And so I have secant squared x. Sine over cosine is what? Starts with a T. Tangent. And 1 over cosine is secant. And you're done. And I know you think, oh, but we can factor out a secant. You can, but you know what? All they wanted us to do was rewrite without a fraction. Do I have a fraction anymore? No, I don't. Why would we want to do that? So we can see it through the lens of calculus later on. All right, one more. Now, I wasn't supposed to write equals cotangent. And I'm going to cancel that out in just a minute. This does equal cotangent. That's going to be our answer. I was kind of wanting to show you that this is what we're going to do in 5.2. We're going to do identities where this equals that, and you have to get one side to equal the other side. So at least you know where you're going. Right now, we're just simplifying. So we're going to pretend, we're going to pretend like that's not there. Okay? All right, so here we go.
Need it later?
We'll do it later, yeah. We'll do it in a different lesson. Okay, last one. Ooh, I don't think I have time. We're going to FOIL this whole thing out. So secant times cosecant of theta. Outside is secant theta. Inside is minus tan theta cosecant theta. And then my last one is minus tan theta. And please write the thetas every time, or the x's or the t's. Don't just write secant of nothing. Now you have a whole bunch of jumbled mess now. 4 terms. What I would do is my suggestion would be to change everything to terms of sine and cosine. Okay? So secant of theta is 1 over cosine of theta. Cosecant of theta is 1 over sine of theta, plus secant is 1 over cosine theta, minus tangent of theta is sine of theta over cosine of theta. Cosecant is 1 over sine of theta, and then minus sine of theta over cosine of theta. Okay. Do you see anything that we can do? Ooh, I do. This is exciting. Do you see this right here? This is times. And I have a sign up top and a sign on the bottom. So I can reduce those. And what did I end up with there? A negative 1 over cos. Look what's next to it. A positive 1 over cos. So those are gone. And so right now I have 1 over cosine theta sine theta minus sine theta over cosine theta. I'm going to finish this. If you need to go, that's fine. I need to get a common denominator here. So I'm going to multiply top and bottom by sine of theta, so that I'll have cosine sine and cosine sine for my common denominator. When I do that, I get 1 minus sine squared all over cosine sine. And are you getting used to these Pythagorean identities? What is 1 minus sine squared? Do you remember? We just had this in the last problem. Cosine squared. Good. Okay. And now these, I know I'm going fast, sorry. These are all factors, so we can, there's 2 cosines up top and 1 on the bottom. We can reduce, leaving me with cosine of theta over sine of theta, which is cotangent theta.